Winter School. Yesterday we covered a very interactive session. We started with 15 people yesterday, and now I can see we have a lot of people. Today is our second day. Let us try to recapitulate exactly what we said yesterday. Okay? Just a small revision about what we went through. We said that the Winter School deals with 5 concepts or 5 topics. The first one is solving the problem. Is that correct? We said yesterday. How to solve the problem. We came up with 4 points in order to solve the problem. The first one, we've addressed a table called input, processing, and output. So, before solving the problem, the first thing that we said is read carefully your statements, highlight all the important points, and after that, reformulate your statements based on what is important and take away what's not important. Therefore, you have to come up with a table called input-output processing. Within that table, we have input side, we have process side, and output. In input, you have to put all the concepts related to input. We have identified few keywords for input. The first keyword is enter.
Set.
The second one, set. The third one, input. These are the keywords often used within to identify the input concept. These keywords can be used into your pseudocode. Okay? So, you are not going to mix them. The first you said enter, second one set. You must choose any of these 3. Is that correct? Now we move out to processes. We found few keywords for processes. The first one was such as
Calculate.
Calculate. The second one,
If statement.
if statement. Very good. The third one, however.
Hi guys, I'm not the student here. You have to speak.
The fourth one,
Determine.
determine. What else? Loops. What type of loops?
While loop and for loop.
While loop, for loop. What else? So the processes are based on any manipulation of your program. So when we are talking about calculate, it means things related to addition, calculation, subtraction, division, and modulus, and so on. Okay? That's a process. Things related to cases. If statement. Okay? Where we found as well the Boolean expression where it's true or false and so on. All these are the keywords used with the process. Now, what could be the different keywords used for outputs? We said the first one was display. Another one is solving or solution. What else? Or solution. What else?
So,
Yes?
we didn't discuss this yesterday, but can return also be an output?
Return.
Yeah.
Yeah, return. Often return is used in process. Okay? Return is used in process. The output is just what you can see. The final solution. What can be given. The expected. Do you get that? So these are the keywords used for you to solve the problem. Okay? So now, to solve a problem within business application in logic and design, we have a first to pass through input, process, and output. Now, once you have discovered what is the problem, how it is a problem, and what could be the expected solution, therefore, this step will lead you to another process called pseudocode. We have defined pseudocode as plain text, English plain text. Your pen, that you have your mind, that you write down, but that text must be written logically, step by step. Okay? That plan or that pseudocode must be written using all these keywords. A pseudocode is written based on this table. I'm only trying to do a revision of what we went through yesterday. Okay? Quickly. Now, your pseudocode, you will extract your pseudocode from the keyword you found here. You start writing your pseudocode step by step. We've said that a pseudocode starts first of all with a title. A title of a pseudocode is written. At the end of it, there is a column. Okay? Assume that you read your statement. After reading your statement, you have to extract or to give a title to that problem. Okay? And that title, at the end of the title that will be given, must have a column. Without a column, the person who's going to mark you will mark you with 0. Secondly, the first start before starting your pseudocode, we start with the keyword start. And at the end of the pseudocode, we have the keyword end or stop. You can also use start or begin. Okay. Your pseudocode starts always with these two keywords, start and stop or end. Now, the content inside of your pseudocode must start from the end of the last letter of the word start or last letter of the word begin. Okay? So then, why we start in the middle? Because we are using Python. We are trying to make sure that the content is inside and we can avoid indentation. Because Python does not use curly braces, we use indentation. Indentation is the white space. To avoid error for indentation, we said yesterday that you press one tab and then your content is pushed inside. Okay? Then we start putting your pseudocode in details, everything from there. Now, within your pseudocode, we mentioned again something yesterday that however you come whereby there is an if statement in that pseudocode, okay? At the end of that if statement, there is a then. T-H-E-N. Without using then, your pseudocode is wrong. Okay? When you finish with your if statement, at the end of if statement, you must close that if statement with and if. It means you open the if statement and you close the if statement. Okay? Sometimes, like yesterday, we went more developed or advanced exercises. We found if and we found also as if. When you found if and as if, that means you said, okay, you tried the first time, it works. It gives you something else. Then you said, okay, let me try again with this one again. Do you get that? It means I tried this one, let me try this one again. At the end of as if, there is also a then. Then when you put as means otherwise. Do you get that? Means otherwise, and at the end of it, you close it. Correct? Now, that is what we said in terms of pseudocode. Later on, we moved to algorithm. We've defined yesterday an algorithm as a step-by-step instruction. The algorithm instructs the hardware, instructs what to do, but what you'll be doing will be step by step. So you're not going to jump or to skip other spaces or other actions. You follow everything step by step. I've given an example yesterday by saying, me as a human being, I'm an object. I can instruct myself to talk to you, to step up, to step back, to write on the board. Do you get that? I've given another example about a car. When you drive, you stop, you reverse. Okay? So step by step, everything is done step by step. That is the algorithm. Your algorithm is 100% your pseudocode. Do you get that? But to differentiate your algorithm from pseudocode, we represent your algorithm into a flow chart. Okay? Now, that flow chart, just a second. We came up to the algorithm. We say that the algorithm is represented into diagrams. Input is represented by a diagram called parallelogram that looks this way. This is for input. When you do your algorithm, you don't have to write for me input here. You have to tell me what is input here, the content of that input. Assume that my input was enter number 2. I will write immediately here, enter number 2. I'll write that. But the design will be that shape of parallelogram. Point number 2, output. Output has the same shape as the input. This is the shape of output. And you have to comply with that. Once you give a shape which is totally different from these shapes, the person as your lecturer, whoever, will mark it as a 0. There's no discussion about that. Maybe we'll give you 1 mark for the content that you put there, because each shape counts 3 marks. So you'll be getting like 1, and you'll be failing. Processing or process. The shape of a process is a rectangle. And you have to know all these shapes. When you do your process, assume that in your process you have to calculate the amount you do. You have to calculate the total of all those inputs. You must give all these processes step by step. Don't put all the processes in one box. Are you getting that? So you put all the processes step by step. Process 1, process 2, process everything that's related to process. When it comes to an if statement is represented by a diamond. That is your if statement. This if statement has 2 options, either true or false, and you have to identify. You cannot give if statement without showing it. That if statement, if it's true, it means it is the output of your if statement. How will be the shape of output of if statement? You comply again with that. The same apply here as well, because it's an output. Output looks that way. Okay? We moved down, we went to what else again? Yeah, all these diagrams are connected from one another with arrows or lines. So you cannot put them without connecting any of them. You have to connect them. They must be connected. At the end of your if statement, okay, assume that this end of your if statement, you must close your if. As we said, you open it and you have to close it. You end that if statement. You must show it how you close that if statement, and then you carry on with your work. Again, here we are coming to maybe display whatever. So as we said, the algorithm is 100% of pseudocode. It starts with the keyword start. The start is represented in the circle that way, and then you will do a stop here this way. This is what we said about the algorithm yesterday, and we went through a lot of exercises that some we started nicely, and we end up with more advanced and more complicated things. Anything else that I forgot, guys, who came yesterday? I think we end up on something like that. So today we'll be doing the problem statement 3. Okay, we'll be going again slowly. The first condition is we must read internally carefully to understand what the problem entails. This is the problem. Johnny has some money saved in the bank on which he earns an annual interest of 9.5%. Johnny needs to enter the amount he has saved, then calculate the amount of interest he earns every month. For the sake of calculations, you can assume that an equal amount of interest is earned every month. Calculate and display the income tax he must pay on the interest rates according to the values in the table below. We have given interest rates. Less than 1,000 rands, the percentage is 0. From 1,000 rand to 2,000 rands, the percentage is 72 on amounts that should be greater than 1,000. 2,000 to 3,000, the percentage is 9.5 on amount that is greater than 1,100. Now, as you see the case, in order to solve this case, the first thing, as I said, we read it carefully, and then we start picking up all the input, output, and processes. The first step is we have to write down a table in order to solve that problem. Okay? Now, we'll be doing together in details so that those who just come today, they can also understand. Look at this. When you look at this statement, I gave here input as saved amount that Johnny has. What could be any other inputs you found there? Because we didn't give all the inputs. I'll be writing on the board, we have to identify all of the inputs. That is step 1. Let us work together.